Alright, so today we'll be going over the basics of IFR flight planning. We're going to start off with departure procedures, and starting with that will be the standard instrument departure, or the SID. So for this theoretical flight plan, we're going to be starting at Los Angeles International. And actually, what we're going to do is first come up with the general route. So we're starting at Los Angeles, and we're going to be going to San Francisco International up here. So in general, you want to go into a flight planning software or FlightAware, and you type your original point, your departure airport, in our case, Los Angeles, and you then type your arrival airport, San Francisco, and that in ForeFlight here will give you a straight line, but we're not going to be flying a straight line, and nor do airliners or any other aircraft in general, not when IFR. So depending on what software you have, there is some location that is like the route advisor here. In this route advisor, it'll show you a list of all these cleared routes that that different aircraft have taken. It looks like this procedure here is the most common. So we click that, and we would get this procedure here: the Los Angeles Sumer 2 departure to Stoked Surfer, and then the Surfer 4 arrival into San Francisco. Now, it automatically gives you both an approach, or a SID, and a star. We're going to go over the SID first. So we're going to go in to Los Angeles, and we're going to find our departure procedures. We're going to look for the Sumer 2 departure here. Now this is an RNAV departure. And typically at Los Angeles International, the departure runways are either runway 25 right or 24 or 26 left. So when departing these runways, the ATC will give you a clearance, usually something along the lines of RNAV to Docker, this waypoint here, which means that you fly direct to this first waypoint. Then from there you join the departure procedure as it is shown in your flight plan. So from the Sumer 2 departure, you're going to the Stoked transition, which is up here at the top. So when you depart 25 right here, you notice that there's this 3000 with a line over the top of it. That means you are required to stay at or below 3000, meaning you're not supposed to climb above 3000 feet before you reach Docker. After you cross Docker, the next waypoint here is Ivos, and this one has at or below 5000. So you can climb, after you cross Docker, you can climb from your 3000 that you were staying at up to 5000 feet. after that, I believe it looks like an unrestricted climb up to your top altitude, flight level 230 feet. Flight level 230. Because I do not see. Actually, wait. Right here, dark. It has another altitude restriction, 12,000 feet. So the departure procedure is funneling you along onto a standard route that you can fly. And this is the Sumer 2 departure. So it ends at Sumer. And from there, you go to your transition. In our case, we have the Stoke transition up towards the
I have a
top here.
question here.
Yep.
So if we have, like you said, on dark, we have 12,000 feet as restriction. So if the next waypoint doesn't have any restrictions, it means you can fly to top altitude, or the restriction from the previous point still stands?
You follow the restrictions of the next
Okay.
the next waypoint. Or
Okay.
the ones after it. So it looks like from here it's all maintained about 12,000. They want you to fly
Yep.
about that altitude. So once you hit dark, you typically want to hold 12,000 until you hit stoked here, and then you can continue your climb to your cruise altitude. So the stoked transition is where the transition is where the departure procedure ends. It could be any one of these: Vicky, Dinty, Mickey, Stoked, Scatter. And that's all of them. That's where the departure ends. From there, you will continue on with your filed flight plan. So we come over here. Stoked is where the departure procedure ends. From there, we go to our next waypoint, which is just right here, Surfer. And then we start the Surfer 4 arrival. Before going over arrivals, I'm going to cover direct flight. Sometimes you can chop all of this out, so it just looks like this, but that is more common at smaller little airports. So if you're departing like a little uncontrolled field, like Paso Robles right here, we look, and in the procedure, they do have a departure procedure, but they do not have an arrival. And when you're flying from these, you can usually just take off, and you could theoretically fly direct from this airport to, looks like this one's probably, no, that's not certified for IFR. Where's that? Here's one that's IFR. So it has two approaches here. So you're able to fly direct. So when you take off, you can fly direct from your small little airport straight across to the other airport, your destination. But you're not going to be landing like VFR. You're going to follow the approach procedure. So you fly straight to an initial approach fix and then into the airport. That's what direct would be. But most of the time, you're going to have some waypoints in between to kind of organize the traffic flow. So right now we're gonna cover waypoints and navigation aids. So the main navigation aid before the advent of GPS was the VOR. Now the VOR is a little bit of a confusing thing to get a grasp on, but I have this simulation here which can kind of give you an idea of how the VOR works. So the VOR stands for VHF Omnidirectional Radio Beacon. And it spits out a beacon all 360 degrees. And from that, you're able to find your location off of that, the bearing and radials. So we have our little airplane here, and our VORs are here in the center. We can take our airplane and imagine that we're flying. We have our CDI here, and let's set CDI so that it is set to due north. So now this is has the bearing or the radial off of it. The from radial is going straight south, or the to radial comes straight south, and from is straight north. So if we fly our airplane across it, on the south side, or on the from side, or the to side of the radial, sorry, we have the to indication in the CDI here. As we come along and start to cross the radial, the CDI needle will start to center until we're flying directly off of that, off of the VOR on the 180 radial. It shows right there, 180 degrees off of this VOR. Now, if we take our airplane and we turn it straight towards the VOR and start flying towards it, as soon as we cross the VOR, we hit the cone of, as we're crossing it, we hit the cone of confusion, and the needle flies off to the side and starts kind of wobbling back and forth. And the to indication becomes a from indication, meaning that you're flying from the VOR on the bearing of 360 degrees. So whatever you have this set to, if you have a from indication, you can find where you are relative to that. So we can turn the OBS here until till the CDI shows a from indication and the needle centers like that. So the needle is centered, and we can see that this is the 116 degree radial off of it. And so from that, we can plot 116 degrees, and we find our location is along this bearing off the VOR. Do we have any questions so far?
I guess that's just the steam gauge cockpit, right? It looks a bit different on the glass cockpit, right?
Yeah, it's a little bit easier to show it with the steam gauges,
Yeah,
but the airliners do have kind of little needle on the primary flight display that will show you kind of the VOR. It varies from airplane to airplane, but this is the easiest one to kind of understand. Now, some VORs have a DME along with it that you can measure the distance from the VOR. But you can also use GPS distance from it for the navigation. So now we can go back to our chart here. And we have these airways here, Victor Airways. You can see that these are coming off of the VORs, and they have different numbers. The numbers is just an identifier, but if we scroll in here, you can see that we have Victor 137 has a bearing of 0.88 degrees off of this VOR, the Gorman VOR.
So if you were to fly towards it, you'd have to set 180 degrees from it, right?
So
you want to fly towards
if we're flying, so say we're like over here by Tafto, and we want to fly to this VOR. We can go into here, and we can see that this is the 297 degree radial. We can scroll over, set it to 297, which is just about 300 degrees. Now, since we're over here, we'll turn our airplane around here. We notice that we have the from indication, and we're flying to the VOR, so that's not going to be very ideal, because as when you're flying to it, when you have the to indication, like here, and you're flying to the VOR, the CDI needle points in the direction that you need to go in order to intercept the radial. So if we're a bit to the left here, the needle turns to the right, indicating that we need to turn right to be on center. If we go to the right, it points to the left, meaning that we need to turn left to get back on center. But if we flip around to the other side and have the from indication, it thinks we're flying away from it. So if we're to the right of the VOR, the needle points to the right, which would technically mean that if we're flying away from it, we would need to turn to the right to get on course. But since we're flying to it, we would need to turn left, which can be very confusing to pilots. And so when we're flying to a VOR, we want to have the to indication, and to get that, we flip this 180 degrees. So we're going to go turn it so the OBS has the 119er degree radial at the top. So we turn it all the way around like that. Now we have the to indication, and so it accurately depicts which direction we need to go. So now we can fly to the VOR here. Now, as you notice, as we get closer to the VOR, it starts to drift off to the side. This is because as you get closer to the VOR, a smaller movement indicates a larger change in the angle relative to it. So if you're flying by the side of it, by the VOR, you can see that the angle quickly increases and then flips around. So as you get closer to a VOR, you need to make smaller changes to stay in the center. Now, once we cross the VOR and hit the cone of confusion here and get to a from indication, now we look at our chart, and we're trying to fly the Victor 137 airway. So now we're going to want to turn to the 088 degree radial, so we can turn our OBS to 088 like that. Now we need to turn our airplane And so now we've turned the airplane and we've turned the the OBS, and now we will end up start lining it back up on our track like that. Any questions so far?
Yeah, I have a quick one for you, Aviator.
Okay.
Do you, when you're flying with the radial from the VR, is it like the heading, or
Yeah,
is it
you're
the?
going to line up the, so you notice that east is 090 degrees. And so to line up our airplane, you got the little indicator here pointing this direction. To fly along the radial, we have to line up our heading indicator with this. So you want these two to match, and you'll be, if this is centered, you'll stay on course. But if your
Right,
airplane,
yeah.
if the heading is off, either you need to reset your heading indicator to the compass, or you're going to be flying off course, and it'll slowly drift. In which case you need to turn your airplane in the other direction to fly back to correct the drift.
All right, yeah. So when you're over the VR and you fly heading, let's say the 080,
Yeah.
that's the same thing as radial 080, I guess.
Yeah, well, the radial is off of the
More
VOR.
or
The
less.
heading is irrespective of where you are. So right here, we're flying a heading of 088 degrees, and our bearing shows to be 013 degrees. So the bearing is where you are relative to the VOR, but your heading is the direction your airplane is pointed in.
So they should match, basically, yeah.
Yeah, if you're on course, the needle will be centered, and your heading and CDI will be the same.
More or less, because if you have like strong winds, you might want to, head away from the course, and the wind will correct for you. But other than that,
Yeah, if you have some wind, you'll have to add some wind correction angle here. And so, if you look on your GPS, the track of your airplane will be what this is. You want the track to line up with this.
yeah, correct.
So that's how VORs work. Now we have intersections right here. Oh, also, these airways have altitudes. These numbers here are the minimum altitudes that you need to fly in each direction. So if you're flying east on the Victor 137 airway, we want to maintain at least 8,000 feet. If you're flying west, you're going to want to maintain 9,000 feet. When you cross it, you're going to have some new altitude restrictions here. So this goes from 900 feet and bumps up to 1,000 or 10,100 feet. Which, considering its location...
So are you showing right now like the lower altitude airways or something? Because
yes, these are the
I
low
guess they're
altitude
higher
airways currently.
as well.
We can switch over to the high chart.
Oh, okay.
In which case we have the J routes, as well as Q routes.
And where can we find the restrictions here, or are they not there?
So the restrictions are because of terrain. So if we go
Okay.
back to, where were we?
Oh, so that's minimum
Gorman.
self-altitude, basically.
These are the minimum altitudes. If we go to the VFR chart and look on here by the Gorman VOR, we can see that there's like 8,000 foot mountains here. And so flying to Gorman, our minimum altitude here is 9,000 and then bumps up to 10,000. So we've got about 1,000 foot buffer in this area, so we don't crash into mountains. So intersections are where two airways cross and give you an intersection. So that's kind of where you would turn to go to some other point. And then there's RNAV waypoints, which is just random GPS points scattered around the map for various navigation purposes. They, as far as I'm aware, have no rhyme or reason for being somewhere, but they are used in different approach and departure procedures. So that's covered the en route section. Going back to the departure procedures, we can find another thing that's different from a SID. It's the obstacle departure procedure, the ODP. These are usually much simpler. So say we have this airport here, Meadows Field, and we're taking off runway 30 right. So our obstacle departure procedure here, for all aircraft on all runways, it says a climbing right turn direct to the shafter vortex is the departure procedure. So we can go in here and switch over to the VFR map so it's a little easier to read. We take off our runways, and you do a climbing right turn to shafter VOR right here. That's a pretty simple departure procedure. Well, actually, this is probably a little easier to understand. This is a pretty short one. It's departing runway 8 with standard climb rate or a minimum climb of 282 feet per nautical mile to 8,000 feet. So using your ground speed, you can convert this to feet per minute climb rate, which you need to be able to match to be able to do this departure. Now, runway 26, the obstacle departure procedure is not authorized. So instrument departures are not authorized off of runway 26 due to terrain. For the departure procedure for runway 8, it wants you to use Okako RNAV departure. So you don't need to use a departure procedure at all airports, but if you're using the IFR takeoff minimums, you want to use these ODPs to avoid terrain. Does that make sense? Any questions?
Yeah, where you find them? Also in ForFlight?
You can find them in various places. All of these resources are all free online for the US. Other countries are annoying in that they are hard to find the information, and it all looks considerably different from each other. But you could just search up obstacle departure procedure for whatever airport you're trying to leave. In general, this is only applicable for smaller airports. And the larger airports will use the SID. Let's cover airspace. So, switching to the IFR chart, if we go down to Los Angeles, we have this nice, big, messy blue area, which is the Los Angeles Bravo airspace. Along the lines here, you see the numbers B 2,000 to 10,000. The first number is the bottom of the airspace in that location, and the top number is the top of the airspace in that location inside this box. So, if you have not been cleared into the Bravo airspace, you can legally fly below 2,000 in this area and above 10,000 in this area. Now, if we look around, all of these areas top out at 10,000 feet. So, if you're flying across this area and you don't want to mess around with having to be cleared through the Bravo airspace, you can just file your flight plan for above 10,000 feet. But if you do need to go through the Bravo airspace, you have to be specifically cleared by an air traffic controller to enter it. Let me bring up whiteboard so we can draw something. So Bravo airspace in general has kind of a rather messy area. It has a central kind of column, and then it juts out and then steps
It's like
up.
a reverse wedding cake, right?
Yeah, it's the reverse wedding cake. And so you have all of these areas that go up, and then it tops out at about 10,000 feet here. Inside of these areas, you can have little areas of like delta airspace underneath it, which you can see here. Like Long Beach has a big delta airspace area topping out at 2,600 feet. Another one here at 2,400 feet. And these areas have their own control towers that are separate from the main Bravo. Now, if we switch from there to Alpha airspace, Alpha is everything above 18,000 feet. And above. Up to, I think it's around 60,000 feet, which is much higher than basically anybody flies. To enter Class Alpha airspace, you must be on an IFR flight plan. And as such, VFR traffic is not allowed up there because of the speed of the aircraft that are traveling up here. It's hard to maintain visual separation. Now, about with the airways, we have the high altitude airways at the that are above 18,000 feet. And which is the J and Q routes. And below 18,000 feet, we have the low altitude airways. Which is usually, or which is the Victor Airways and T routes. The airways are off, or the Victor Airways are off of BORs. I'm failing to remember what the T routes were for, but they have a different purpose and they're a bit less common than the Victor Airways. I can post that later on. But that basically pretty much covers airspace for IFR. Well, then there's the Charlie airspace, which if you're in contact with ATC while you're flying IFR, you're pretty much guaranteed to be allowed to fly through Charlie and Delta airspace without any extra hassle. No clearances or anything required because you're already in contact with an approach controller or a tower controller. But you must be cleared into the Bravo airspace. And you do not have to be cleared into Alpha airspace. You just have to be properly certified and equipped for it. Any questions so far?
You also don't need clearance for Delta, but you need to have established communication with the controller, right?
Yeah, same thing for Charlie. Yeah. And for the most part, except in some rare circumstances, usually when you're landing at an untowered airport, you will always be in contact with an approach controller or center controller or tower controller when you're flying through areas. And so since you're already in contact with them, you already have two-way communication established, so you do not have to worry about flying into these airspaces. Let's go over frequencies for VORs and such. So every VOR has a specific frequency to it, which you have to input into the nav part of the radio stack in order to be able to use it. And the frequency for every VOR is a different one. So we can have this VOR is 110.4. And here's another VOR. Lake Hughes is 114.35. And I don't know if most simulators simulate it, but if you can tune the ID to get a Morse code identifier, which is this part right here, which will give you its identifier, LHS, and every VOR has its own identifier, which you can input into your flight plan to add it to your route. Another thing is when you're filing or when you're inputting your flight plan into your FMC, GPS, MCDU, whatever, in general, you don't input the name of the Victor airway, but let's find a route with an airway on it.
You just pick an intersection, I guess, and then guide it to another.
Yeah, pretty much. Here's one with intersect or with
a highway.
See. Here we go. We got the Victor 299 airway, which has a slight turn. Coming off of here, it's 276 degrees, which is slightly different from the 093 degrees here. So this is a little bit of a turn right here. So when you have an airway, we're flying from the LAX VOR to Ventura VOR. You input the first and last waypoint on that airway and any turns. So if you're just going straight through and there's not a turn, which this barely looks like a turn, but it is, you would input SADI right here into the middle of the flight plan to give you the same thing. So we can replace this because we have LAX and Ventura, so these are both in our flight plan here. We can replace V299 with SADI. And it will give us our exact same flight plan. So that's how you would enter it into your flight computer. Just your initial waypoint on that airway, any turns, and then the final waypoint. I've gotten a lot of questions about that, so I wanted to clear that one up. Any questions about that?
So you go for every, like, you have Tango 257 and like 259, and you would go in and check for any turns, and if there aren't any, just remove the airway anyway from the flight plan?
Yeah, pretty much.
Yeah.
Yeah, we can see that there's no turns here. There's no I don't even believe there's any intersections along this airway. So yeah, it looks empty. So you would just input RZS to MQO onto your flight plan, and that would give you the route along this airway.
Sure, because it's guiding you between 2 points. It's a straight line anyway.
Yeah, that's what airways are mostly, an established route between two waypoints that's commonly used, and so it's easier to have your traffic flowing along them versus just randomly distributed everywhere. They also give you the guaranteed obstacle separation, since you have these altitudes that you have to follow.
Mm-hmm. You would be given altitude anyway, right?
Yeah, you'll be assigned a cruise altitude, and they can amend that as needed.
Okay. So how do you, for example, transition from low altitudes to high altitudes if you have like a longer flight plan that will have you fly, at cruising of 45,000 or something like that? So how do you transition from low altitudes to high altitudes in the flight plan? Just after the departure, the SID, or
The high
how do you
altitude
transition?
chart is typically used for cruise, so you'll usually
Mhm.
follow. Well, these charts are the airways are typically used for cruise, but they can be part of um, you can use multiple different ones, but in general, once you transition to above 18,000 feet,
So I mean, if
you'll
you plan
use
to
different
fly
airways.
high, you have to plan for like departure anyway. So you're gonna use the low airways, and then how do you transition?
Now the thing is, you don't have to stay on these airways.
Mhm.
You can go off of them, but then you have to follow the MOCA, which is the minimum off-course altitude, which is shown as this kind of
Okay,
shaded
same as VFR
number.
map,
So it's
basically.
7,500 feet is the minimum altitude in this square here, this
Mhm.
like box. It might be a little bit
This
hard
is
to see
same
it on
as
the
sectional
screen.
chart, right?
Say again?
Same as sectional chart, right?
Yeah.
Okay.
This is the lowest altitude that you are guaranteed to not hit anything inside this square. So when you're off of these
Yeah.
airways, you gotta maintain above the MOCA.
Mhm.
Somebody asked, would you have to request clearance by ATC to change the altitude at a waypoint along the track? If you're following the restrictions put by the airway, no. But if you're cruising along above that altitude and ATC has cleared you for a cruise altitude, you'll have to request a clearance to change your altitude or you can request a block altitude to which allows you to climb and descend as you need within that block that they give you. Which is useful when you encounter some rough turbulence and stuff, because it's really hard to maintain a specific altitude if you're, say, in a thunderstorm or something. Let's see. Let's go to approaches. Actually, no, arrivals first. So coming into Los Angeles, let's switch back to that original route we had. Here, Surfer 4 arrival. So we could go in and find our arrival plate, Surfer 4. And if we look at here, here is our the transition for our arrival server. And we have different holds here that they can tell you to hold at these points. So if you're flying in and they tell you to hold at the surfer waypoint, you can you follow a 10-mile long loop and just hold there. Go in circles. So surfer is the initial point of the published arrival. And just like our departure, we have altitude restrictions. So before Nurly, you have to maintain 2,800 feet, or actually no, this is a speed restriction. The K is knots. So the speed restriction is you have to fly 280 knots, no slower, no faster, before hitting this point.
That's indicated?
Correct.
Okay.
And at or above flight level 200. After crossing that, our next speed restriction is again 280 knots, but at or above, or below flight level 190 and above 15,000 feet. So you have some space that you can follow as you're descending here. Just to kind of allow you to step down. And then our next point, we have again 280 knots. And top altitude is 15,000 feet. And at or above 10,000 feet. As we hit fullet, our speed restriction drops to 240 knots. And at or above 8,000 feet. And you notice that there's no top. So anything above 8,000 feet after epic. Then we continue on to Eddy, which is the end of our arrival route. So from Eddy, you continue on to your initial approach fix along your arrival. Now, they have a description in these approach and departure procedure, or arrival and departure procedures. That's kind of a worded way to easier understand the route. And some notes about what you can expect.
So that speed restriction is the top speed or the speed that you have to keep?
The speed that, so these bars, if you have a bar on the bottom, you have to be above it. If you have a bar on the top, you have to be below it. So these speeds have a bar on top and bottom, so you have to maintain exactly 240 knots. I mean, plus or minus a couple, I guess. They're not that picky.
What if you have the aircraft that doesn't have that performance?
You're probably not going to be flying this route that starts at 2,000 or 2,000, 20,000 feet.
Yeah,
You're not going to be flying your 172 in at that altitude.
yeah, it's good.
So this is an arrival that's specifically used for jets, and they can
Okay.
travel these speeds.
Yeah, that's perfect.
So we go back here, and we go into our arrival route, and we can see that coming from this direction, we're probably going to want a runway 28 left. I mean, it can depending on it can change depending on the relative winds. We can take our approach, and 28 right. Let's take the ILS 28 right. Actually, let's look at RNAV first. RNAV 28 right. So the approach procedures have a lot of information on them, and we're going to go over that right now. Starting out, you have the approach course. That's the track that you got to fly to that the runway is lined up with. The runway is 281 degrees. Then some basic information about the airport. You have 11,236 feet of runway landing distance available. So if you need longer than that, then you're in trouble. The TDZE is the touchdown zone elevation, which is 13 feet, so we're pretty much at sea level. The airport elevation is also at 13 feet, meaning it's pretty flat. Because you can have an airport with a hill on it, or an airport that's on the hill, so your airport elevation and the touchdown zone elevation will be different. That's more important if you're flying faster jets with auto land and stuff. This, in general, for simulator use is not terribly important. These are just notes about it. This is the type of approach lighting system. So the lighting system changes depending on the airports. Some airports have better lighting systems, some have worse, and the minimums for your approach partly depend on the lighting system that they have, as well as the navigation equipment. Then we have the missed approach procedure, which is something you always want to have briefed when you're flying an approach. Because if you cannot make the landing, then you have to fly this missed approach. So once you decide that you have to go around, you do a climbing right turn to 3,000 feet on a heading of 030 degrees, then direct the Oakland VOR and DME and hold there. They show this on the chart here. Is the climbing right turn, climbing up to 3,000 till we hit the VOR DME, and then we just hold here until you have set up everything and you know what you're going to do next, whether you're going to try and shoot the approach again or divert to an alternate. Any questions about this top section here? No? All right. So here we have our different frequencies. First is the ATIS, which is the weather. You tune in to get the weather there. We have approach control. This 338 frequency is only for military use. Civilian band is 134.5. So in general, ATC will hand you off to each different frequency. But if you forget what they told you, if they told you to contact ground and you forgot what the frequency is, you can look out here, see it 121.8. Here we have the minimum safe altitude, which is from Darn, right here, which is your missed approach point, within 25 nautical miles of Darn. The slowest you can safely go is 5,100 feet from this point. Here's the next really important section. So we have altitude restrictions again here as you step down to all of these different waypoints. So from it was yeah.
Mm.
Question?
Hallå. Tryck på escape. Och sen trycker du på din profil, ditt skin där. Och sen trycker du på participation så väljer du på sitting out. Mm.
Say what?
I private dock. Jag måste sända till public. Oh, sorry.
Okay, no problem. Let's see. So from the end of our arrival procedure, we had from Eddie, we will fly direct. When you're clear for the approach, you fly direct to the initial approach fix. Now, an approach can have multiple initial approach fixes at different points, which all kind of feed into the main approach. We can see here that our initial approach fix is Annette. At Annette, you must be at or above 7,000 feet. After crossing Annette, you can step down to 6,000 feet. And every time you cross the next waypoint, you can step down another about 1,000 feet in this case. It varies depending on the approach, but in this case, it's a very convenient 1,000 feet for every single waypoint. When we hit go back here, this is the final approach fix. And usually the final approach fix is where you want to be fully configured and have everything set up for landing, especially if you're flying light aircraft. That if you're flying heavier aircraft, you want to be fully configured a bit further back, but no further than the final approach fix. From here, we have our minimums. Darn at 1,140 feet, where you either immediately go missed or continue on for your landing. As it shows here, the decision altitude for LNAV VNAV approach is 1,140 feet and 4 miles visibility. These are pretty high minimums, and it's for all categories of aircraft. So from really slow Cessnas to really fast jets, they all use the same minimums. Here, this is the angle of the glide path, 3 degrees, meaning that'll typically match the happy lights on the side of the runway. So you can transition from the glide slope here to the Pappies. Along the bottom here, we have kind of the distance between each waypoint. So 3.1 nautical miles between most of these waypoints. And again, here is shown a visual representation of the missed approach procedure. And because this is a non-precision approach, it has a decision altitude versus a
Minimums? Don't know what you're looking for.
All approaches have minimums, which is these here. But there was the decision altitude and the minimum descent altitude. This one has a decision altitude. And then here, the little star indicating that there's a note up here. Saying that if you have to go around after you pass Darn here, you have to have at least a minimum climb of 380 feet per nautical mile until you get to 18,000 or 1,800 feet. That pretty much covers this approach chart. We also have the ILS approach chart, which is approximately the same thing. It has a lot of the same information, saying the different runway lightings, its missed approach procedure, all the frequencies. The main difference is we have this Maltese cross at the final approach fix, at which point you must be on glide slope with the the glide path indicator on your CDI or whatever panel, and on the localizer as well. So the difference between this approach here, the RNAV approach, and the ILS is that the RNAV is a GPS approach, meaning that it uses information from satellites and to give you your position. But the ILS or localizer is a radio beacon positioned on the airport that spits out this kind of beam shape that you are able to track down to the runway. In general, ILS is the most precise. I think it's the only precision approach you can get, which means you need an ILS to do an auto land. And we can see the minimums are much lower than on the last approach, which was 1,140. This approach has minimums of 213 feet above the ground and a visibility, an RVR of 1,800 feet, which is about half a mile. And this is for all categories of aircraft. As you can see here, we have two separate ones, some for the slower categories and another one for the faster categories. This one requires a higher visual range, but the same minimum altitudes to decision height. And then the circling approach is where you follow the glide slope in until you hit your minimums and until you break out of the clouds, and then you have to stay within 1.3 nautical miles of the runway threshold, and you can circle around to the other runway and land on the opposite side. That's usually done for wind. You can see that it's not authorized for Category D aircraft, which is really fast. Now, the ILS works rather like the VOR does. We can go in here and switch it to ILS. And so here we say we have this little beacon. This here is, imagine our runway. We can have our airplane back here. And say we're low on the glide slope, but centered on the localizer. You'll have the center needle, the localizer needle is centered in the CDI. But you can see that this needle is pointed up. That means that we are low on the glide slope, and so we would have to climb up to be able to capture the glide slope. Or because the glide slope is at an angle, you can just continue flying forwards until it automatically kind of lines up. But if you continue in level flight, it'll continue going down until you're well above the glide slope, in which case you would have to have a rather steep descent angle to manage to get back on it. As you get closer to it, you can see it becomes more sensitive, so I do a tiny movement here of the mouse, and you have a big deflection of the needle. But back here, you do the same movement of the mouse, and there's a much smaller deflection of the needle. Just like the VOR. So as you get closer to the runway, you have to make smaller and smaller adjustments to stay centered. Does that make sense? Any questions?
So glide slope captured for ILS means basically not that you're flying on autopilot, but that your plane is on track with a glide slope, basically, right?
Yeah, correct. Because you don't have to have an autopilot to fly any of these approaches.
Mhm.
I flew this approach just yesterday, and I hand flew this approach just yesterday. But it just means that you just have to get to the point where you're in the middle of the beam and you have the CDI centered, and then you just track that all the way down to the runway,
Yeah, perfect.
staying centered. Of course, it's a little easier to keep the needle centered when it's not a mouse,
Yeah,
but
and when it's the sim or the airplane, not
yeah.
program.
Now there is a phenomenon where that it can give you false glide slopes at a much steeper angle. So like up at a 6-degree angle and a 9-degree angle, you can end up capturing a glide slope. So the 6-degree glide slope is upside down. So it acts as if as you climb, it looks like you're going lower, but as you descend, it looks like you're going higher on the glide slope. So it's all backwards. But the 9-degree one is just as normal, but you'll notice if you're on the false glide slope because it'll require like a nose dive straight towards the ground to keep on it. Like it's incredibly steep. And which is why you're supposed to capture the glide slope from below. So when you're flying on your approach, you don't go above the glide slope, you just capture it from below till it drops down and you're centered, and then you just track it down to the runway. Let's switch to, well, also, you notice that here we have both ILS and localizer. The localizer is the ILS without the glide slope portion. So it's like you're just tracking it in like a VOR, flying your airplane, following the middle, but then you're following these little step down altitude restrictions. So you gotta basically you descend to 3,000 feet till you hit SEPIN, then you drop down to 1,800, and then you can drop down to your minimums, 480, until you hit your visual descent point, which at 3.2 miles from the runway, or the DME off of the ILS, from the runway, the other end, 3.2 miles off of that, is your visual descent point. When you hit that, either you if you can see the runway by 3.2 miles off of on the DME, if you can see the runway, you can continue in and land. If you cannot see the runway, you continue on and do your missed approach from there. Does that make sense?
So that box, that box is the DME.
Yeah, this box is the distance from the radio transmitter. So,
not from the runway. Okay.
yeah, so
Just
so
'cause
this
that
black
doesn't-
line is the runway here. And we can see right here, this is 1.3 nautical miles from the runway. But this shows 3.2, meaning that the beacon is on the other side of the runway. You may have seen at airports, you have that little kind of red spiky antenna thingy at the end. That's the localizer. And that is what this is measuring the distance off of. So once you hit the visual descent point indicated by this big dark V, that's when you either can continue in or do your missed approach. Now to continue on to some more interesting approaches, I know of one VOR approach. Like here. Maybe it's here. Yeah, we have a VOR alpha approach. So if we zoom in here, we have all of the same information as all of the other approach plates. You got a missed approach, minimum safe altitude from the shafter VOR, and so on. And here is our initial approach fix, which you always fly to initial approach fix. And here is a holding procedure. So if you're coming in from a different direction, like if you're coming in from like the west here, you're gonna need to fly like a teardrop pattern. So you cross the VOR, then you're gonna turn right, and then you fly to it, and then you stay in the hold. But usually when you find this is called a course reversal or a procedure turn. You hit this, you do a teardrop, and then you come in and continue on the approach. Now, if we zoom in really far here, you'll notice that the runway here that we're trying to land on is not lined up with our approach. Which is why you have some rather high minimums, about 1,000 feet, because when you, and they're only circling, because you're having to circle into the runway here, sort of. You're having to make a pretty drastic turn to get in. And also, you're flying the radial off of this VOR. So you go into your CDI and you turn it and set it to the 269 radial from the VOR, and you just stay on that until you end up the missed approach point is 4.5 on the VOR. And you'll notice that the numbers count up as you get closer to the runway versus down like the last approach, because you're not measuring from the runway, you're measuring from the VORTAC here, which is the final approach fix. It's both the initial approach point, you capture it, you do the procedure turn, and then it's the final approach fix. And then from there, you can descend down to the runway. And if you cannot see it by the minimums, you continue on until you're at the 4.5 on DME distance from the VOR, which is at the runway threshold, and then you can execute your missed approach point to this lovely sounding intersection. and minimums just as normal. So any questions about this approach? Oh, and one more thing. We have this chart here, the final approach fix, which is this point, to the missed approach point, which is this point. If you you reference your ground speed to see how fast you're going. So let's say you're going 90 knots. The time between this point and here, you can put in the timer, is 3 minutes. So as you're descending down at 90 knots, if you hit minimums, you just continue there until you've been going for 3 minutes, and then you execute your missed approach procedure. The one last approach we have is a really interesting one that I like to fly. It's called the DME arc. So our initial approach fix is right here, WOGIG, and you're flying a fixed distance from the VOR here. So when you hit WOGIG here, you turn 90 degrees to the left, and you...
Hello, Aviator of Doom.
Yep.
Ah!
Question?
Anybody doing a flight right now?
No.
I'm about to do a flight in America.
I'm sorry to interrupt, but can you mute me?
I don't have the power to mute people.
Okay, thanks.
So for flying the DME arc, you have to maintain a specific distance from the VOR, which just shows 23 miles. And you look on your DME, and you kind of fly it kind of like a localizer, but you're trying to keep the numbers at the 23. And so every 10 degrees from the VOR, you go in here and you turn your OBS. So, actually, let's go back to VOR, DME. So, if you look at this chart, we first see that we're at the 196 degree radial. So we can set this to 196. Yeah. So we turn our airplane, and we're flying from it. So now we have our VOR centered. And as we turn our airplane and follow the DME arc along, it's going to start turning. And every 10 degrees, or actually, once you cross it, you're going to turn the CDI 10 degrees and continue flying until the needle lines up. And then once it lines up, you turn it another 10 degrees as you keep turning the airplane to follow the arc. Until we hit this 319 degree radial, in which once you hit 319 degrees, you turn another right 90 degrees, and then you follow in to the VOR, straight to it, 319 degrees, until you get to the runway, in which it's also offset, so it's going to be trickier to land. Also considering that this is a rather imprecise approach, being so far away from the VOR, there's going to be quite a distance of error that you have flown. meaning that this has some rather high approach minimums, 900 feet. So that's about all I'm going to cover for today. If we have any more questions, feel free to ask them now.
Wait, how much fuel does it take?
For what?
What we just did.
For the flight from Los Angeles to San Francisco?
Yeah, I guess so, yeah.
Well, it depends on the aircraft you're flying. The aircraft that I have it set to here, it shows 32 gallons, which is perfectly within the range of my aircraft. 311 nautical miles, take about 3 hours. A lot of flight planning software will automatically calculate the amount of fuel it requires to fly the route that you have selected. And a lot of them will actually take into account the winds, in which case we have a 1 knot tailwind, which is nothing to be not very impressive, but every bit counts. It'll cut down on your fuel consumption a little bit.
Does it take legal minimums into requirement?
No. It just tells you the amount of fuel required. From there, you have to use your own judgment to figure out how much extra fuel you want to add. So, because you need a minimum legal time of 45 minutes when flying IFR, that's about 6 gallons for me. So I would have to add 6 gallons to this amount to be able to legally fly this.
Wait, how fast are we going? What would be the general?
About 110
fast?
knots in my airplane, which is why it's 3 hours for this.
Okay, wait.
Yeah, you couldn't fly that approach to them, right? 110 knots, 240 knots.
Yeah, because of the speed restriction, I could not fly the arrival, but I could fly the approach.
Okay, sure. That's what I meant. Yeah.
Yeah. So there's different approaches and arrival procedures for different types of aircraft. ATC has kind of a list, and they'll assign. If you try and input something into your flight plan that's incorrect, that you're not allowed to do, they'll amend your flight plan and tell you the route that you're actually needing to fly. So if, say, SUMR 2 or departure does not work, they'll tell you what departure procedure to follow.
Okay. And that'll be the first controller, like on the ground, or any
Yes, this
controller
will
on the
be
road?
clearance delivery before you even take
Mhm.
off.
And he will check the arrival as well, or just the?
He'll check your entire route to make sure that it lines up with their standard operating procedures and letters of agreement with other control centers, and so on.
Okay.
Wait, how fast are we going again?
110 knots around.
But it does not. The speed doesn't affect too much. It just affects what types of arrivals and departures you can use. There's I don't know if ForeFlight tells you.
Okay, thank you for answering my question. Oh my god.
ForeFlight doesn't tell you, but there are other softwares that I do believe tell you what I think.
Navigraph probably does
Yeah,
that. I don't know.
yeah. SimBrief will. I think it tells you what
Yeah, sure.
approaches are for jets and what ones are for turboprops and piston. But ForeFlight does not tell you that. So it's partly up to your own judgment, and you don't have to be perfect. ATC will amend your clearance if they find that there is a mistake. So that takes some of the pressure off of you as the pilot.
So another question that I have, because for like VFR flying, you have some weather minimus, and here I guess only like if your airplane is certified for the certain crosswinds or something is taken into account, and the minimums for approaches.
So the only minimums you really have are the minimums for departure if you're flying Part 121 and 135. As Part 91, you do not have departure minimums that you have to legally follow. You can take off in absolute zero visibility. Is that a smart idea? No, it's not. But it is
True.
legal. Now, for approaches, you do have to follow a certain minimums to be able to land. So basically, the landing minimums are the only ones that you really have to abide by. But so it's considerably different from VFR, where you have to stay a certain distance from clouds and have a certain number of a certain amount of visibility.
Unless it's like Bravo and just clear of clouds, right?
So, any more questions?
Do you have to actually pick an alternate as a legal requirement?
Ah, yes, excellent question. So, it depends on the weather conditions at your arrival airport. It's 1 hour before and 1 hour after. The visibility has to be at least 3 miles and 2,000 foot ceilings, if I'm remembering correctly.
And that's based on TAF, I guess.
Yes. So yeah, it is 1 hour before and 1 hour after your estimated time of arrival. The ceilings have to be above 2,000 feet above the ground, and the visibility has to be at least 3,000. Oh, and the airport has to have an instrument approach.
And instrument approaches ILS, VOR, DME, and is GNAV?
Yeah, there's
It's not,
RNAV,
right?
ILS, and localizer, VOR, and the DME ARC. And then there's a few others other than that, but those are the main ones. In general, you're flying RNAV and ILS. You very rarely see the other ones, but they do exist.
And do you also check like I don't know SIGMETs or something like that for flights?
Yeah, that's part of your go no go decision. Yeah, you look at the SIGMAS to see if there's a lot of convective activity, a heavy icing. You got to check kind of the freezing layer in our airplane because we're not certified to fly into icing conditions. So if it's like freezing at 2,000 feet and the clouds are at 2,000 feet, then we're probably not going because you have to climb above 2,000 feet, meaning you'd have to climb through those clouds and you're going to pick up
And we
ice.
don't want to die.
Yeah, and you don't want to break the law either.